Well, hi there, boys and girls. Today we're going to talk about area between two curves. The first thing I'm going to show you is why we do our integrals the way we do. So let's consider a function f that I have right here. I'm going to call that f. And then let's say I've got another function, and we'll have a different function g. So we'll have g down here, g of x. And let's say we wanted to find the area between the curves between two x values. Let's say we wanted to find it between x equals a, draw my little line better than that, x equals a and x equals b. So what we would want is we want to find all of this area between the curves. Now, one way to do this, I'll call this a and b, one way to do this would be to find the area under f from a to b. And that would be a positive area. But what if we integrated from a to b the value of g? Now, if we integrate the value of g between a and b, this is going to definitely be less than 0 because the area is all underneath the x-axis. So this will be a negative value. But with area between these two curves, I want to find a positive answer. So what I'm going to do is I'm going to integrate between a and b f of x, and then I'm going to subtract the integral from a to b of g of x. Now let's make sure that makes sense to you. Why would I subtract this value? Because this value is negative and I need this total area to be a positive answer. So I'm going to do the area under f minus the integral from a to b of g. Now this can be shortened so you don't have to do two integrals. We can call this the integral between a and b of f of x minus g of x. Now, it does not matter where the x-axis is. What you have to do, if you want to find the area between two curves, is make sure you are always doing the top function minus the bottom function. You will always find a positive area if you do it that way. Let's get right after this and see some examples. So here I've got the definite integral that represents the area of the region enclosed by 4x minus x squared and the x-axis. Now what you do not have here is you do not have a graph. You don't have a picture of this. So it would be nice for us to find like the roots or the zeros or the solutions of this. When does this equal 0? Well, let's factor out an x and we'll get 4 minus x. And we get that x equals 0 and x equals 4. And this is a negative quadratic, so it shouldn't be too hard for us to graph this little thing. I've got roots at 0 and a root out here at 4, and it's a negative quadratic. You know it reaches its maximum halfway between there, so its maximum is up here somewhere. You could actually plug in 2 to figure out what that is. So this is a graph of that negative quadratic. I missed my 4. There we go, a little bit better. Now we want to find the area between that graph and the other graph. The x-axis has an equation. That is y equals 0. That's this graph right here. So looking between 0 and 4, I've got a bounded region. This is a region R that's completely bounded on the top by 4x minus x squared, and it's bounded on the bottom by y equals 0. And so what I'm going to do is I'm going to integrate between 0 and 4, top function minus bottom function dx. Of course, minus 0 doesn't really make any sense, so this answer is A. Let's do another one. The area of the region bounded by the graphs of y equals and y equals 0, and now we actually have to find it. So I need to find the zeros of this graph to see if I can graph it. So let's factor it. First of all, we can factor out an x. X squared minus 6x plus 8. And then I can factor some more, so I have x times x minus 4 times x minus 2. This graph has 3 roots. It's a cubic, so it can potentially have 3 roots. So I've got a root at 0, I've got a root at 2, and I also have a root at 4. Now, you know this is a positive x cubed, which goes down to the left and up to the right. You should have learned that in pre-cal. So this graph looks something like this. Down to the left and up to the right. Now I want to find the area between this graph and y equals 0. So I want to find the area. Notice what happens here is that from 0 to 2, the cubic is the top function. But from 2 to 4, y equals 0, or the x-axis is the top function. That means I need to separate this into two separate integrals. I will do the integral from 0 to 2 of top minus bottom, and that was x cubed minus 6x squared plus 8x. I'm not going to do minus 0 there. And then I'm going to add to this the integral from 2 to 4 of 0 minus x cubed. Now that will make a difference if we put 0 minus. 0 plus doesn't make a difference, but top minus bottom here, we're going to have to turn this around. So let's go a little further and see what this would be. So this would be x to the 4th over 4 minus, that's 6x cubed over 3 plus 8x squared over 2 evaluated between 0 and 2. And then plus, now over here if we clean this up, that's going to be integral from 2 to 4 of negative x cubed plus 6x squared minus 8x. So that's going to be negative x to the 4th over 4 plus 6x cubed over 3 minus 8x squared over 2 evaluated from 2 to 4. Now, since I want to keep this video as short as possible, we know to plug the 2 in and then plug the 0 in and subtract those. I just want you to see it. I'm not going to evaluate it right now. So this would be 6 times 2 cubed over 3 plus 8 times 2 squared over 2. And then minus, plugging in 0 is just 0. Then we're going to come do this integral. So this would be 4 to the 4th over 4 plus 6 times 4 cubed over 3 minus 8 times 4 squared over 2. This will matter. Now we have to subtract. Then we plug in a 2. Negative 2 to the 4th over 4 plus 6 times 2 cubed over 3 minus 8 times 2 squared over 2. So you would have to do all of this math, and again, I'm not going to crunch those numbers right now. So there was an example of one where we had to do 2 separate integrals. Now let's do area between 2 regions where one of them is not the x-axis. X squared minus 4x, that's not going to be too hard to graph, and neither is x minus 4. So graphing x squared minus 4x, I know if we factor this, this has a root at 0 and it has a root of 4, but it's a positive quadratic. So we know at 2 it reaches its minimum. So that looks something like this. So there is x squared minus 4x. Now x minus 4 is down here at negative 4, has a y-intercept of negative 4, and it cuts up like this. So we'll go through like that. So it's going to intersect this graph twice. And when y is 0, that's not actually out there at 2, but you get the picture. So we have to find some intersection points here. We have to find where these graphs intersect. Actually, when y is 0, x is 4, so this graph should have been graphed right here. We're going to fix that real quick because that's not a good graph. This goes up 1 over 1, so it should look like this. Should look like that. Now let's say I don't know that it looks like that. What we can do is we can set these two equations equal to each other to find their intersection points. So let's get everything on one side. So x squared minus 5x plus 4 equals 0. And we factor. And we get the solutions are 1 and 4. That's where these graphs intersect each other, at 1 and at 4. So what I'm going to do to find the area is I'm going to do the integral between 1 and 4 of the top function minus the bottom function. We're actually going to crunch the numbers on this one. So let's clean it up before we integrate. X minus 4 minus x squared plus 4x. So that's going to be the integral from 1 to 4 of 5x minus x squared minus 4. So let's go ahead and do this. So I've got 5x squared over 2 minus x cubed over 3 minus 4x evaluated between 1 and 4. So let's plug them in and do it. Okay, so we've got 4 squared is 16, divided by 2 is 8, times 5 is 40. 4 cubed is 64. 4 times 4 is 16. So there's plugging the 4 in. Minus, now let's plug the 1 in. 5 halves minus 1/3 minus 4. So let's see what happens here. 40 minus 16, that's 24. 64 thirds. Now what happens over here? 5 halves minus 1/3 minus 4. Boy, that gets messy. Let's call all of those, common denominator would be 6. So let's call that 15 over 6 minus 2 over 6 minus 24 over 6. So I've got 24 minus 64 thirds minus, so that's 15 minus 2 is 13, minus 24 is negative 11 sixths. Went down too far. So now I've got 24 minus 64 thirds plus 11 sixths. So I guess I'm going to do, well, common denominators again. Why not? We'll make them over 6. So that's going to be 6 times 20, that's 120. 6 times 4 is 24, so that's 144 over 6 minus 128 over 6 plus 11 over 6. Okay, so 144 minus 128, well, that's 16 plus 11. Looks like we got 27 over 6, which we divide by 3, we can get 9 halves. Boy, that was a lot of math. I sure hope I did all of that right. I hope 9 halves is up here somewhere. So let's see here. Whew! Okay, it's positive 9 halves. All right, last thing I'm going to show you is on your calculator how you can answer this. And so on your homework tomorrow, you're going to actually use your calculator on some of the questions. So here I've got to find the area between these two graphs, and so what you do is just simply take your calculator out, put them in y equals. There's f and g, and then you can go to the graph screen and we can calculate their intersections. We can go math, intersection, first curve, second curve. Now lower bound means move just a little to the left of the intersection. Upper bound means move a little to the right. And so I've got one intersection, it looks like that's 0, and it's at 0. And the other intersection, first curve, second curve, you can actually type these in. It looks like a lower bound is 2, and an upper bound would be like 5. You can just hit those numbers, and we're going from 0 to 3. So this would be, and which one is on top? You can see the negative quadratic, that graph is on top. So anyway, we're going from 0 to 3. The integral from 0 to 3 of top function, always do top minus bottom, minus bottom function, and then since this is a calculator question, you can just type this in on your calculator from the home screen and get your answer. So anyway, I'm going to cut this off now, and we're going to do area tomorrow, and I'll see you guys then.